All right, so now let's divide some exponents. So remember the rule, if the base is the same, I just subtract the powers. So x to the, they're both the same, so I'm going to write this as x to the 9 minus 3, which equals x to the 6th. Number 8, bases are the same, so I'm going to write this as negative 3 to the 4 minus 2, which is negative 3 to the 2nd, or negative 3 squared. Sorry. I'm going to skip number 9 and jump down to number 10. Bases are the same. I have 4s at the top and bottom, so 8 minus 5 becomes 4 to the 3rd. For number 11, I have f to the 10 minus 9 and g to the 7 minus 1, which equals f to the 1st, g to the 8th, and I'm actually just going to write it as f g to the power of 8. 7 minus 1 is not 8. 7 minus 1 is 6. Ding, ding. Sorry. That's my tired brain. 6 and 6. So we just don't write things to the power of 1. You can use it to help your brain think when you're mathing it out, but we actually just don't write it that way. So again, I'm going to freeze the screen. You do number 9 and 12, and I'll unfreeze it in 2 hot seconds. Hopefully I can actually subtract. We'll see what we get. Remember that if you have 2 numbers, 2 constants, and you can reduce them, you should, like 15 divided by 3. So for number 9, my final answer is m, right? 10 minus 9 is 1, so m. For number 12, 15 divided by 3 is 5. The a term, 4 minus 2 is 2. The b terms cancel out, right? Those just cancel out. I've got the same number in the top as in the bottom, so they just go away. 5a squared, c. Are we good with that? Do you guys feel okay about that? Do you remember any of this from previous years? Okay. So the power of 0 is weird, just because it's kind of hard to wrap your head around. So I'm going to start with a number, like using a number that we know. So I know that 3 to the 1st power is 3. I know that 3 to the 2nd power is 9. And 3 to the 3rd power is 27. Each time I'm taking like the next step, the next step is to take the previous term and I'm multiplying it by 3, right? To get this term. I would do the same thing. Well, what if I wanted to work in the opposite direction? Like what if I wanted to go this way? I would divide by 3, right? So 27 divided by 3 gives me 9. 9 divided by 3 gives me 3. So 3 to the 0 is whatever 3 divided by 3 is. What is 3 divided by 3? 1. So we're not going to learn this today, but I'm going to pique your interest. What about 3 to the negative 1? Well, that's just 1 divided by 3, or 1/3. Okay? So the idea is that you know that any number or variable to the 0 power is going to equal 1. Any number or variable to the 0 power equals 1. Okay? Does that make sense? Okay. So let's just try doing these really fast. So what's 3 to the 0 power? 1. What is x to the 0 power? 1 times y to the 0 power. 1 times z to the power. 0 power is 1. 1 times 1 times 1 times 1 is 1. So you don't know this rule yet, but this is saying take this whole thing to the power of 0. What does that mean? The whole thing equals what? 1. This is saying 4 times 1 because it's not grouped in a parenthesis. This is saying 4 times 1 because x to the 0 power is 1. 4 times 1 is 4. A lot of times I see things to the 0 power as 0, and that's not true. Not true, not true. Okay. Negative exponents. We are doing that today. I thought we were doing negative tomorrow. Maybe I double up. So negative exponents, just like I kind of showed here. So when you have a negative exponent, still the same rule. This is 1 minus 4. 1 minus 4 is negative 3. So this is really x to the negative 3. But when you have a negative exponent, you reciprocate it. And you make the exponent positive. So you write the reciprocal and you make the exponent positive. Here's how I remember this. Has anyone ever slept in a bunk bed? Yes. Okay. We've all slept in a bunk bed, probably. So I'm in the top bunk. So I'm going to refer to this one. X to the first divided by x to the fourth. The division rule says that I subtract these. This is the same thing as 1 minus 4, which equals x to the negative 3, which is what we started with. This is in the top bunk because there's no number below it, right? So I'm going to put a 1 below it. When I'm in the top bunk and I'm sad because I'm negative, the only way to make me happy, I'm like fussing. My mom's like, fine, get down to the bottom bunk. And now I'm happy. So nothing is in the top bunk, but we know with fractions, something has to be in the top bunk. You have to put a number there, right? So 1. Okay. If I have 5 squared over 5 to the 5th, well, 2 minus 5 is negative 3. So same thing. I'm in the top bunk and I'm sad. My mom's like, stop your fussing. So I move down to the bottom bunk. 1 over 5 cubed. So what if I'm in the bottom bunk? What if I'm down here in the bottom and I'm throwing a fit? What's my mom going to tell me to do? Get to the top bunk. Stop being a whiny butt. But 2 to the third power over 1 is just 2 to the third power. You see that I'm taking the fraction and I'm reciprocating it and changing the power from negative to positive. So I always think of negative exponents as being in a bunk bed. If you're in the top bunk, you don't like it, move to the bottom, and vice versa. Does that make sense? Okay, so let's practice that. Okay, so x to the negative 2 power in the top bunk. This is over 1. What am I going to do? Move to the bottom bunk. Reciprocate that fraction. Okay. Let's look at number 18. What's sad? What part of that x, the 8x cubed to 8 to the negative, 8x to the negative 3, what part of that is not having a good day? The x. The x is what's unhappy. The 8 is fine where it is, but the x is the one that's fussing. So I need to move it downstairs. When I look at number 9, the whole thing, this whole thing is unhappy. The whole thing is fussy. So I need to put a 1, because remember, this is over 1, right? So I'm going to reciprocate it. Let's look at number 20. Well, the first thing I know is y to the 0 is what? 1. So I'm just going to rewrite this as 5x to the negative 4, because anything times 1 is just that number. What part of this is not having a good day? The x is not having a good day. The x is fussing. So the 5 is going to stay in the top. The x is going to go to the bottom. Let's look at number 21. Do I need to move this at all? No. 4x squared is good. The negative portion needs to go down to the bottom. What about this? Thank you, ma'am. What about number 22? The entire thing is unhappy. Yeah. So once I move it to the bottom, do I need to group it back in a parenthesis? Because that's going to become a positive 1. Everything to the power of 1. So do I really need to group that? No, because it's just to the first power. You can, but you don't have to. Like, I'm not even going to put the 1 there because anything to the first power is just itself. Okay. What do you think? Okay. So let's try this. So we're going to use the rule that says when you're multiplying powers, you add the base. So this is -3 plus 1. And then we're going to use the negative rule if we have it. So -3 plus 1 ends up to be x to the -2. But I can't leave a negative exponent. It's just mathematically gross. It's one of those things that we're just not allowed to do. So how do I rewrite that? Yeah, 1 over x squared, or 1 over x to the second. Let's look at number 24. So I'm going to focus on my m's first. So I have m to the -5 plus 3 times n to the 1 minus 4. Okay. Or 1 plus a -4, if you will. So what does my m become? Well, that becomes m to the -2 and n to the -3. They're both unhappy. So I'm going to drop them both. And now they're happy. Did you all do exponents last year in pre-algebra or whatever math you had? Okay. So number 25, this is f to the 2 minus 7. Because when I divide, I subtract the exponents. Well, 2 minus 7 is -5. I can't leave it like that. What do I need to do to that? Drop it down, write it over 1. 1 over f to the 5th. Number 26, I'm going to reduce this. I'm going to take care of this and this. So 10 over 25, I'm going to reduce this, divide them by 5. So that becomes 2 over 5. Does everybody see that? Do you see what I did? I divided the 10 and the 25 by 5. So I still have a 2 on the top and a 5 on the bottom. But then this x becomes x to the 7 minus 9, which is x to the -2. That's not happy right there. And this becomes z to the 1 minus 1, which is just z to the 0. So I'll write it here just so we can think about it for a second. So what do I need to move? What do I need to change up? The what? The x, where am I going to put it? Down in the bottom. And what about z to the 0? It's just 1. Do I even need to write times 1? No, because anything times 1 is just itself. So there's your answer. Okay. We're almost done. Cut. Powers of powers. So you guys know that typically when you have a number outside of a parenthesis, you have to distribute it. You're very accustomed to distributing. We do the same thing with powers. If I have an exponent raising another exponent, so it's called a power of a power, I'm going to distribute that. So what x squared to the third power really means is x squared times x squared times x squared. But if I use the rule, well, that means x to the 2 plus 2 plus 2, which is x to the 6th, which is the same thing as taking the number on the inside and multiplying it by the number on the outside. So when you have an extra exponent on the outside, when you're taking a power and you're raising it to the power, you can simplify that by multiplying the two exponents. When you do that, it's important to make sure that every term has an exponent on the inside. Every single number, constant variable, has a term like a power on the inside. So I'm going to first of all rewrite 2m to 2 to the first, m to the first, to the power of 3. Because I want you to see what's going to happen, right? So now I'm going to take each one of these and multiply it by 3. So that becomes 2 to the third, m to the third. And I could simplify it one step more because 2 to the third is actually 8. So I actually am going to write my answer as 8m cubed. So think about what I did. There was no power or exponent on the 2 and the m, but remember that it's understood that those are to the first power. So I put ones there so that I know when I'm multiplying everything by that 3 on the outside. So when we look at number 28, I'm not going to rewrite this one. I'm just going to squeeze a 1 right there because the -3 is the only thing that does not have an exponent on it. So that becomes, if I distribute this, that becomes -3. Notice I'm putting that in a parenthesis. 1 times 2 is squared. X to the what power? 10. 5 times 2 is 10. Y to the 14th. Can I simplify the -3 squared? -3 times -3 is what, Tessa? 9. So I'm going to rewrite this as 9, x to the 10th, y to the 14th. Okay. So for number 29, everything is being raised to the 5th power. Everything in the numerator and everything in the denominator. Because if I were to expand this, it would be like x squared, y to the 4th over 2. And I would just keep repeating that, right? So you see that the 2 is also being raised to the power of 5. Do you guys see that first off? Because it's important to understand that when you have a fraction, everything, numerator and denominator, are both being raised. So I'm going to put a 1 here. And then I'm going to distribute this power to everything. So that becomes, let's see, x to the 2 times 5, which is 10. Y to the 4 times 5, which is over 2 to the 1 times 5, which is, and I'm going to simplify it one more step because I know that 2 to the 5th power is 32. So x to the 10th, y to the 20th. Thoughts? Good with that? Okay, so let's talk about homework. Okay, we're going to do notes for 3 and 4 tomorrow. We're going to do 3 and 4 notes tomorrow. I want you to do page 5. I want you to do page 5 and let's talk it out. I'm going to circle the ones that I want you to do. So we're going to do all of page 5. So page 5, all, which is a lot. That's a lot. On page 6, I want you to do this. And that's it. Okay.